an independent editorial analysis of Japan's defense posture and security policy.
The operational silence within the Combat Information Center of the Mogami-class frigate is striking. It stands in stark contrast to the labor-intensive coordination required on the bridge of an Asagiri-class destroyer. This acoustic and ergonomic difference represents more than just a generational leap in naval architecture. It signifies a fundamental existential crisis facing the Japan Maritime Self-Defense Force. As the organization confronts a severe demographic contraction, the logic governing fleet composition has shifted. It has moved from purely capability-based metrics to a calculation dominated by human capital management. The trajectory of the Asagiri-class, once the backbone of the escort flotillas, is no longer determined by the structural integrity of the hulls, nor is it defined by the lethality of their armaments. Instead, it is driven by an unsustainable requirement for manpower that Japan can no longer generate. The impetus behind the accelerated procurement of the new FFM frigates is inextricably linked to the retirement of legacy platforms. A comparative analysis of crew requirements reveals the stark arithmetic driving this transition. The Asagiri-class demands a complement of approximately 220 personnel to maintain combat effectiveness. In opposition, the highly automated new FFM design achieves superior situational awareness and kinetic output with a crew of merely 90. This reduction of nearly 60% is not merely an efficiency gain. It is a structural necessity for a maritime force that consistently misses recruitment targets. Retaining the Asagiri-class in active service imposes an opportunity cost that the JMSDF can no longer afford. Every crew member deployed on these legacy vessels effectively prevents the manning of two modern platforms. This creates a paradox where maintaining numerical fleet strength actually degrades overall readiness. Because the human resources required to operate legacy sensors and manual weapon systems are siphoned away from the advanced network-centric warfare capabilities inherent in the new frigate program. While the domestic utility of the Asagiri-class has diminished, the strategic value of these hulls has inadvertently appreciated within the context of regional security architecture. The revision of the three principles on transfer of defense equipment, combined with the establishment of the Official Security Assistance Framework, has created a mechanism to convert these retiring assets from a disposal liability into a tool for diplomatic leverage. This potential transfer is particularly relevant for Southeast Asian partners such as the Philippines, Vietnam, or Indonesia. For these nations, the primary deficit is often not high-end missile technology, but rather seaworthiness, endurance, and command and control facilities capable of withstanding the hydrological conditions of the South China Sea. In the context of gray zone coercion, the physical displacement of a vessel becomes a tactical attribute in itself. Paramilitary forces and maritime militias often utilize hull size and mass to intimidate smaller Coast Guard vessels without firing a shot. The Asagiri-class, with a full load displacement approaching 5,000 tons, provides a kinetic counterweight that smaller offshore patrol vessels simply cannot offer. It allows a recipient navy to hold the line in contested waters, resisting physical encroachment and ramming tactics through sheer naval architecture rather than escalation to armed conflicts. From a systems integration perspective, the Asagiri-class offers a specific capability profile. one that smaller patrol craft cannot replicate. The displacement allows for a stability profile necessary for sustained operations in rough seas. This is a critical factor for maintaining a persistent presence in contested zones during typhoon seasons when lighter vessels are forced to return to port. Furthermore, the existing hangar and flight deck facilities provide an organic anti-submarine warfare capability currently absent in many regional coast guards. The ability to embark an SH-60 helicopter extends the sensor horizon of the task force by hundreds of miles, transforming a single surface combatant into a wide-area surveillance node. However, the transfer of such complex systems introduces significant logistical and financial trade-offs that must be weighed against the immediate capability gains. The propulsion system of the Asagiri-class relies on a combined gas or gas arrangement utilizing 4 Spey gas turbines. While this configuration provides rapid acceleration and high speed, it creates a fuel consumption profile that is significantly more expensive than diesel-based systems. For a recipient nation with a constrained defense budget, the operating cost could prove prohibitive. It risks relegating the vessel to a harbor-bound status rather than an active deterrent. This economic reality suggests that any transfer agreement would require a comprehensive support package to ensure the platform remains operationally viable. This necessity for support opens a secondary strategic avenue for Japan, the export of its defense industrial base. By transferring legacy hulls, Tokyo is not merely providing hardware. It is creating a long-term dependency on Japanese technical expertise, spare parts, and maintenance cycles. And the domestic shipbuilding industry, heavily concentrated in giants like Mitsubishi Heavy Industries, faces its own challenges as the JMSDF consolidates its fleet. The maintenance contracts for exported Asagiri-class destroyers could provide a vital revenue stream, keeping the specialized workforce and supply chains active, even as domestic orders for legacy components cease. Therefore, the transfer becomes a method of subsidizing the Japanese defense industrial base using the defense budgets of partner nations. The challenge of interoperability further complicates the potential transfer. Integrating NATO standard weaponry and a proprietary Japanese combat direction system with non-Western logistical chains presents a formidable technical hurdle. Countries operating a mix of Russian, European, and American hardware may find the specific electronic architecture of the Asagiri-class difficult to assimilate. The maintenance of aging electronics, specifically the OPS-24 radar components, would require the establishment of a specialized industrial support structure. This indicates that a simple handover of hardware is insufficient. The transfer would necessitate a long-term, institutional commitment from the Japanese defense industry to provide technical expertise, effectively binding the recipient's naval readiness to Tokyo's industrial base for the next decade. This creates sticky defense relationships, where political alignment is reinforced by the practical necessity of keeping the fleet afloat. Strategically, the disposition of the Asagiri-class serves as a litmus test for Japan's evolving concept of remote defense. By empowering partner nations with the capacity to patrol their own exclusive economic zones effectively, Japan theoretically reduces the pressure on its own assets.